So this set of videos, I'm going to explain many of the problems on this Algebra 2 Unit 2b practice test. We did this one in class, but just in case you weren't here, you've got the graph of y equals x. Well, you've got the graph of parabola here, a quadratic function, and then you've got another graph, y equals -2 times x plus 1 cubed, that we're comparing the quadratic function with. So it would be important to note exactly what to do for this graph. Notice that you have a cubic function. The h is -1, so that's our inflection point. -1, h is -1, and k is 0. So -1, 0 is our inflection point. A is negative, so we're going to go down from left to right. So this is really all you need. Understanding the domain and range are all real numbers for this one here. Domain is all real numbers for the quadratic, but the range is all real numbers greater than or equal to 0. And so we just have to identify and place a check mark in each of the boxes, or place an x. It says place an x, so we'll do that. Range of the function includes negative x values, not the quadratic but the cubic. The domain includes negative x values. Well, the domain is all real numbers for both, so yes. Function is decreasing through its entire domain. Well, we could see this function, the quadratic, is increasing for parts, so that's not going to be one that we mark. But we can see that the cubic is decreasing through the whole domain. Which function's x-intercept is larger? Well, the x-intercept of -1 here and 3 there, so the quadratic gets that. The function has a constant rate of change. The only functions that have a constant rate of change are linear functions or constant functions, so therefore we won't mark either of these. These rates of change are changing. It has an inflection point. Well, the only one that has the inflection point would be the cubic, and which is the h and the k. The h and the k over here for the quadratic is your vertex. The function has a minimum. Well, since the range is all real numbers for the cubic, it has no minimum, but the quadratic we can see clearly that it has a minimum. So there you go. For number 2, again, we did this in class, and we've done this before. This is in your cosmic catalog, but I do want to point out one thing. When you have a cubic function that is in the hk form, you want to point out that the h is the number being subtracted from the x, the k is the number being added to the outside, and the a is is the number that's being multiplied. It's the coefficient of this term here, whatever x, could be just x cubed. It's the coefficient of the x cubed term. And so since we have just a minus sign there, the a is -1. And so a is negative, which means the graph is going to be decreasing for all real numbers. And if the h is 2 and the k is 4, then we have an inflection point at 2, 4. And then the graph, again, curls down, kind of curving upward like that, like it's going to come back up. But the inflection point says we're going to go back down like that. And I do want to do one more thing. I want to point out how you find the x-intercept. You let y equals 0, and so we solve the equation 0 equals -x minus 2 cubed. This is always the hardest part. X minus 2 cubed plus 4. I'm going to add this expression to both sides. I'm going to add x minus 2 cubed to both sides. When I do that, a couple things happen. Number one, my x minus 2 cubed becomes a positive number, and the 4 stays positive, and I get the variable on the left-hand side, which is what I really like. And then how do we undo cubing? Well, we take the cube root. So we're going to take the cube root of both sides, and the cube root of something cubed just undoes the thing being cubed. Now, don't you dare put a plus or minus there, because when we have an odd root, we don't have any pluses or minuses. So you can see there's only one x-intercept. So if we add 2 to both sides, then we get x is equal to 2 plus cube root of 4. And so the x-intercept, we would write it as 2 plus cube root of 4, comma, 0. The y-intercept happens to be 0, 12. So if you plug 0 in for x, you're going to get 8 plus 4 is 12. The only other one that I see students typically possibly missing would be the decreasing. So it's decreasing over all real numbers and from negative infinity to infinity. And then the domain also for domain and range, all real numbers. No vertex, no, just NA for the slope, no max, no min, and the axis of symmetry there is none as well. So there you have it.